My name is Santiago Pericas-Gertzen. I am the JAX-RS 2.0 specification lead, and today I'm going to talk about JAX-RS 2.0, which is part of Java Enterprise Edition 7. So before we start with the new features, I'd like to give an overview of JAX-RS and where we come from. First of all, JAX-RS 2.0 builds on the success of JAX-RS 1.x, which is an annotation-driven API to build RESTful web services. But one of the things that we've added in JAX-RS 2.0 is the ability to write also clients for these services. So that's one of the new features we're going to be talking about today. So if you're not familiar with JAX-RS, it's a POJO-based API where resource classes are annotated to build these RESTful web services. Just like any other REST API, it's completely based on the HTTP programming model. So rather than hide HTTP as we've done in the past, with RESTful services, we want to expose HTTP, and we want to talk about verbs like get and put and things like that. It provides format independence. Basically, each of the resources that we have can have different representations depending on the applications and what the clients are expecting from those services. Even though it's container independent, today we're going to focus mostly on Java EE 7. So before we start with the new features, let's take a step back and have a look at what we have in JAX-RS 1.x by looking at an example RESTful service written using that API. In this example, we have an ATM service which has two methods corresponding to two resources. First of all, we can see that this is completely POJO with some annotations. We have annotations like @path that indicate a relative path for this particular resource. We have annotations like @get to indicate the HTTP verb that we're planning on using for a particular method, and also things like @produces to talk about the representation of these resources. The first method we have is balance. The method takes two parameters. The first parameter is what we call a path parameter, and the second one is what we call a query parameter, namely a card ID and the PIN. We're using these two parameters to retrieve the balance of a particular ATM or ATM card. So in this next slide, we see the other method, which is the withdraw method. In this case, it's annotated with @post rather than @get as before. It has a different path, /withdrawal, and because we have an entity coming in and an entity going out, we have two annotations for that, @consumes and @produces. In this case, we're indicating that we're consuming text plain as a representation, and we're producing application JSON as the outcome of this method. The method, just like before, it takes two parameters, a path parameter and a query parameter, and there's a third parameter, which is the amount. This is the entity that we're receiving as part of the request, which is represented as text plain and then converted into a string by the JAX-RS runtime. In this case, we're returning an instance of money, which is a Java class in our application, which needs to be represented into application JSON according to the method. The JAX-RS runtime finds the appropriate message body writer, and thus the serialization of that Java object into application JSON. We're going to talk about the new features in JAX-RS 2.0. These features are the new client API, filters and interceptors, asynchronous processing, and Hypermedia. So let's start. Let's start with the client API. Even though we're talking about REST services, we can use any HTTP client API to access these REST services. It turns out that in practice, using any of these APIs is too low level, and we can actually use some of the objects and concepts that we have in JAX-RS already. So one of the things that we've noticed with the implementations out there after Java EE 6 is the proliferation of client APIs in various implementations for people to use the right level of abstraction when talking to these REST services. So the client API that we have in JAX-RS 2.0 addresses that particular use case. In addition to that, we can leverage providers from JAX-RS, namely message body readers, writers, and a new concept, interceptors, I want to talk about. And by doing that, we reduce the need for proprietary APIs, and we allow our applications to be portable. So let's take a look at an example of what are the kind of things we can do with the client API. We've already seen the ATM service, the RESTful service, and now we're going to see how we can access resources from that service. The client API is a so-called fluent API where we build the request continuously until we're done and we execute the request against the service. So the first step we need to do is we need to create an instance of client. and we do that using a client builder. This is, in fact, an extension point for different implementations to provide additional features. And in this example, once we create that client, we are going to execute a request to obtain the balance from our account, and we do that in multiple steps. Step number one is to create what we call a target. A target is created using a URL, in this case a URL that has path parameters, namely a card ID. And once we create that target, we can actually store that target in a data structure and use it multiple times by specifying different card IDs. In this example, we're going to right away use that target that we create. We're going to specify a particular value for that card ID using the result template method. And then the last thing we need to specify, if you remember the service that I showed you a few minutes ago, is the query parameter, which corresponds to the PIN of that account. Once we specify all those parameters, we create a request. We indicate what is the representation that we're expecting from that request or from that resource. And finally, specify the HTTP operation, in this case a GET, and what is the Java type of the response that we're expecting to receive, in this case a string. The next new feature we have is filters and interceptors. And the motivation here is, once again, we looked around and noticed that these are extensions that different implementations were providing to the users. And the idea behind filters and interceptors is similar to that of message body readers and message body writers, in the sense that they provide the ability to implement cross-cutting concerns in our applications. And examples of that are things like logging or compression or anything related to security like authentication, integrity, and things of that nature. So rather than implementing that logic inside our application, we can put this logic and move it outside of the application and reuse it by multiple applications. We also provide the ability to use these filters and interceptors not only on the server API, but also on the new client API, as we shall see in a moment. And once again, just like we did for the client API, we avoid using proprietary APIs by using the new standard provided in JAX-RS 2.0. So let's start with filters. A filter is something that takes either a request or a response and is going to do some processing on that particular request or response. So we can think of this in two forms, in outgoing messages and incoming messages. So a request is something that initiates on the client and goes to the server. When it initiates on the client, it can go through what we call the client request filter chain. When it's received by the server, it can be processed by the container request filter chain, and vice versa. The response coming from the server is first filtered by the container response filter and then by the client response filter. So one thing to notice here is that we have different types for the client and the server. The reason for that is that the relationship between a client and a server is really asymmetric, and we found that the kind of processing we want to do in a server filter is very different from the kind of processing we do on a client filter. But as we'll see in a moment, that's not the case for interceptors, and that's the reason why we decided to incorporate interceptors in the API as well. Another interesting aspect of filters is that the chain that is formed by all these filters is so-called no wrapping, in the sense that each filter is going to return control back to the JAX-RS runtime before the next filter is invoked. As we shall see with interceptors, an interceptor is actually responsible of calling the next interceptor, so it's a wrapping chain rather than a non-wrapping filter chain. One important thing about filters and this non-wrapping chain is that each filter can decide whether to proceed or not with the chain. An example of that is a caching filter, a filter that finds a cache hit, and instead of continuing the processing of a particular request, it can just return the response and essentially break the filter chain. So let's take a look at an example of a filter. Perhaps the canonical filter is the login filter, a filter that simply intercepts a message and just logs the message in a certain log file or database. A filter is implemented using a class that implements a particular interface. In this case, we're talking about a container request filter, so this is a server-side filter. It overrides a single method called filter that receives a container request context object, and then the context object provides access to anything related to the request. So in this case, we assume we have a log method that takes that request context and is going to do the logging for us. An important point, as I said before, is that this is a non-wrapping chain. So the filter in this case is not going to call the next filter in the chain as it happens in other APIs. Instead, it's going to return control back to the JAX-RS runtime, and the JAX-RS runtime is in fact responsible of continuing the execution of the chain. Okay, so the other thing that we have is interceptors, and let's talk a little bit about the differences between filters and interceptors and why we have two kinds of things for these form of processing. Well, the first thing to notice is that, as I showed you before, filters are different for client and server. And in fact, interceptors are going to be the same because interceptors are used to intercept calls to message body readers and message body writers, which is also something that we reuse between the server and the client. Anything that has to do with processing the entity could be done better using interceptors than using filters. And this is the reason why we have these two flavors of filters and interceptors. The other difference is that the interceptor chain is going to be a wrapping chain rather than a non-wrapping chain. So each interceptor is responsible for calling the next interceptor in the chain, and that's done by calling context.proceed, and we shall see an example in a moment. This is done with any of the two chains, either the reader-interceptor chain or the writer-interceptor chain. So let's take a look at an example of an interceptor. Perhaps the canonical interceptor is the compression interceptor that takes an entity and generates a compressed entity. An interceptor class implements, in this example, a reader-interceptor interface, which has a single method called aroundReadFrom that takes a context, just like the case of the filter. And without looking at the details of this implementation, it's basically just replacing the underlying input stream by a gzip input stream so that when the reader that is going to deserialize the data reads the data, it gets decompressed rather than compressed data. The other thing we notice here is, as I mentioned in the previous slide, we actually need to call proceed to indicate that we want to continue execution of the interceptor chain. So let's have a look at how interceptors and filters interact together by looking at a diagram. In this case, we have a client application that is sending requests over the network and receiving responses from the network. So when a request is ready to be sent, it's first going to be filtered through the filter chain before it gets to the transport. And once it gets to the transport, we still have to serialize the data from the application so that it can be sent over the network. So at that point, rather than calling the message body writer directly as we did in JAX-RS 1.x, we have to go through the writer-interceptor chain to give a chance to all the interceptors to do their work before the message body writer does the serialization. The same happens in reverse when we get a response back from the server. Before we deliver that response to the application, we have to filter that through the filter chain and then pass the result filter response to the application. Now, it's not always the case that the application is going to read the entity in the response. If it does, then we have to go through the reader-interceptor chain before we get all the way to the message body reader. So now we look at the same, but from the point of view of the server. It's a little bit more complicated in this case because we have an additional kind of filter that is specific to the server, and those are the so-called pre-matching filters. So whenever a request is received from the network, we're going to go through the pre-matching filter chain before we do resource matching and before we continue with the normal processing of that particular request. The idea behind pre-matching is that the resource matching process is the process by which we match a particular request to a resource method in one of our classes. And sometimes we want to alter the outcome of that resource matching process, and we can do that by using a pre-matching filter. The rest of the processing is just like we described for the client. We have filters that process the request after resource matching, and then we have message body readers, interceptors, and all the same thing. So the next topic I want to talk about today is asynchronous processing. So let's start by motivating why we have this. First of all, we have support for asynchronous processing both on the server and on the client. So starting with the server, the basic idea behind asynchronous processing is the ability to offload I/O container threads. Whenever we receive a request, if we're running inside a container, the thread that is processing that request is typically controlled by the container. If we have a long-running operation or we're waiting for some sort of asynchronous event that we don't know at what time it's going to happen in the future, we normally don't want to block one of those container threads by doing some additional work or waiting for an external event. So instead of doing that, what we can do is we can essentially get a new thread from a new thread pool, much like a worker in a browser, and do processing in that thread and return the container thread so that additional I/O events can be handled. And that's essentially why we have asynchronous support on the server. This is something very similar to what we've seen in Java EE6 with the introduction of async support in servlet, but now available in the JAX-RS API. On the client side, it's essentially the same thing. If we have a client that has a user interface and we have a thread that controls refreshing that user interface. We normally don't want to block that thread by invoking a certain service and then waiting for that response, and during that time not refreshing the user interface. So much like the way we use AJAX in a browser, we want to use asynchronous request processing in a Java client. So let's take a look at how we do asynchronous processing on the server side using JAX-RS. In this example, we have a resource class annotated with that path. We have an executor defined inside this class. In order to use asynchronous processing, we have to define a method with the @suspended annotation we see here, and with a special parameter type async response. Async response indicates the JAX-RS runtime that we intend to respond on a different thread. Because the execution may take very long, especially if we're waiting for an external event, it's often a good idea to set a timeout handler. In this case, we're setting a timeout handler, and we're setting a timeout of 15 seconds. So if we're unable to respond in 15 seconds, then we're going to abort the execution of this method. And once we set up the handler, we are going to call the executor or use the executor to do the processing in a different thread. Once the processing is complete, then we can get access to the async response object and call resume on that object and return the result back to the client. The important thing to see here is that the request thread in which the request comes is different from the thread in which the response is going to be sent. In other words, the long-running operation method here is going to return immediately, and the thread is going to be reused by other input-output operations. The next topic I want to talk about is Hypermedia. We can spend a long time talking about Hypermedia. For this presentation, I'm going to focus on what are the things that we've added to the API so that you can improve and write applications that are more Hypermedia aware. The first thing we've done is we created support for a new class we call Link, together with a builder for those links. And these classes are based on RFC 5988 web linking, also known as link headers. So JAX-RS 2.0 has support for link headers. And in addition to that, we needed support for producing the links and consuming the links. The production of the links happens on the server side, so we've extended the response builder so that you can incorporate links into your responses. And the consumption happens on the client side, where we look at a particular response and see what links are available and which links we can follow. So let's start with the server side. So on the server side is where the production happens. We're going to define some new links. We're going to associate relationships with those links, and we're going to incorporate those links into a particular response that we want to return. There's a couple of different ways in which we can generate the links using the link builder. In this case, what we're using is we're taking advantage of the fact that we have annotations in our methods, and we're going to generate the links directly from the annotations. In other words, we're going to ask the JAX-RS runtime to introspect those annotations and produce a link for us. So the first link we're producing here is the so-called self link, which is a link that points back to the same resource. In this case, we're talking about orders. Think of them as purchase orders. And the second link that we produce here, it's a ship link, which it's connected to a different method in that resource class, namely handle post. And once the two links are built, then we can incorporate those links into a response so that they're serialized as link headers and sent back to the client. We do that as part of building our response using the response builder, which was already available in JAX-RS 1, but has been extended in JAX-RS 2 to support links. The links method of the builder allows us to specify any number of arguments with links, in this case just two, self and ship. We build all that response, and then we send it back to the client. So once the client receives the response, or first of all, it has to create a request to retrieve that particular response, and we've seen how to do that already. But once the response is obtained, then we can query the response to see if a particular link is available in that response. So in this case, we do order.getLink ship. We're looking to see if there's any link whose relationship is ship available in the order. And if there is, then it means that the order can be transitioned from whatever state it's now to the new state shipped. And in order to do that, what we need to do is create a new request based on the link that we receive. We do that by passing the link to our target method that creates a new target. Then we follow the Fluent API in the same way we've seen in other examples. We construct a request, and then we do a post, which is the method that is required by this particular link. So to summarize, the new major features in JAX-RS 2.0 are the client API, filters and entity interceptors, asynchronous processing or asynchronous resources, and lastly, Hypermedia. We have many other API improvements. I'm not sure all of them are minor. Some of them could be regarded as major. One of them is bean validation. We have a complete integration with the bean validation API so that you can use constraint annotations in your resources, and by doing that, validate requests as well as responses. We've also extended and refactored the request and response classes with additional features. We've improved the URI builder, and we've added some new concepts like string converters, bean param annotation, and hash maps and generic type, and many other minor improvements in the API just to make development a lot easier than it was before. So the main theme of our API and all the things that we've added are primarily focused on ease of use and making it easier to write applications, JAX-RS applications, and also to avoid as much as possible any non-portable extensions that have appeared in many of the JAX-RS implementations out there. I'd like to conclude my presentation by providing some interesting links. The first one is the link to the specification, where you can file bugs on the specification and you can get the latest and greatest about the specification. That's jax-rs-spec.java.net. The next one is the RI website, the reference implementation for JAX-RS 2.0, which is called Jersey. Then we have the user's alias. This is the alias read by all the expert group that is part of this JSR. We have had a really good interaction with our user community, so I encourage people to use this alias to send questions, comments, concerns, whatever it may be. And finally, the link to the JCP or JSR 339 more precisely if you want to get more information about the JSR. And some additional links about Java EE7 SDK. You can go to oracle.com/Java EE for more information about EE7, and of course JAX-RS being an important component of EE7. And there's also some additional links on the slide about Twitter, Facebook, blogs, YouTube, and of course glassfish.org. Thank you very much for listening to the screencast, and I hope you enjoy all the new and great features we've added to JAX-RS 2.0.